Hello students, I am Dr. K.R. Jayakumar, Professor and Head, Department of Mathematics, KS Institute of Technology, Bangalore. As you know, already we are teaching you Engineering Mathematics 2 of the second semester of Code 17 Mat 21. In that, I am doing the first module, already 2 classes. The module name is Differential Equations 1. So far what we have learnt in previous classes, we have learnt what is meant by differentiation, what is meant by integration, what is a differential equation. We know already what is an algebraic equation, the same way what is an differential equation we have learnt. What are all the applications where we can see the differential equations in engineering and technological fields, not only in science. In that, we said there are 2 parts in the solution of a differential equation. One is called a complementary function or CF. For 3 cases, one is unequal roots, another is equal roots, and another is complex roots. We have seen how to find the complementary function for these kinds of roots. And also in the last class, I told there are 5 types of differential equations based on right hand side of the differential equation. One is k into e power ax, second one is sin bx plus c or cos bx plus c, c is constant, b is also a constant. Third is a polynomial of degree n in general. Fourth is e power ax into v, product. V can be either sin or cos. Again x into v, again v can be sin or cos. Out of this 5, we started with the type 1 differential equation. The right hand side consists of e power ax, in general k e power ax. Then to find the particular integral, replace d by a, that is a procedure to find the particular integral of k e power ax form, that is called type 1. And we are using inverse differential operator method. The differential operator, whatever it is there, while finding pi, we write 1 by the differential operator. In that differential operator, you are replacing capital D by a. Generally, you will get the solutions. Then what is the complete solution? Y is equal to CF plus pi. That is a complete solution of the differential equation. What are all the critical forms in type 1 or indirect forms of type 1? While you substituting the value, you may get 0 in the denominator. Last class itself I have shown you so many examples. You have to multiply by x in the numerator, differentiate the denominator, that differential operator, with respect to d, then substitute the value of a in place of d. The number of times it becomes 0 in the denominator, that many number of times you multiply by x and differentiate the denominator with respect to d. That is a procedure we have seen. One more indirect form is, you may be given with cos hyperbolic or sin hyperbolic on the right hand side. So if cos hyperbolic or sin hyperbolic are given, cos and sin can be expressed in terms of exponential functions, then we can do it. You can see the first problem, y double dash minus 4y cos h of 2x minus 1. This is also an important factor, 3 power x. The last class I so told, suppose you get only the constant on the right hand side, say you want to find the particular integral of 5, example. That 5 into 1, that 1 can be represented as e power 0x. So we are bringing it to the form e power 0x and we are replacing d by 0. Here one more form it is given, 3 power x, that also we have to convert. So let us see those two problems. One is in terms of cos hyperbolic, another is in terms of sine hyperbolic. So what is the question? Y double dash minus 4y is equal to cos hyperbolic of 2x minus 1 plus 3 power x. See the first, the simplifications. Standard form is, what is the standard form? D square minus 4 into y. Cos hyperbolic, it is e power ax plus e power minus ax by 2. So, e power 2x minus 1 plus e power minus of 2x minus 1 totally divided by 2. Now this is very important. 3 power x, we should write e power log 3 power x. E power log or log base e is 1. That is why I can write e power log 3 power x. Again we are simplifying, which implies d square minus 4 into y is equal to, separate it, see e power minus 1. So, e power 2x e power minus 1 by 2 plus e power minus 2x e power 1 by 2, this minus is multiplied inside, e power minus 2x plus 1. Here also simplification, e power x log 3. Now I should find out one complementary function for the left hand side, 3 particular integrals for the right hand side for each factor. Now what is the next step? What is your auxiliary equation? It is m squared minus 4 is equal to 0. So m squared is equal to 4, m is equal to plus or minus 2, taking the square root. Now different roots, so therefore what is my complementary function? C1 e power 2x plus C2 e power minus 2x. This is my complementary function. We have seen so many times this. Now let us go for particular integrals. We should find 3 particular integrals. Let the problem be there as it is. So pi1, first particular integral, 1 by d squared minus 4 e power 2x e power minus 1 by 2. This e power minus 1 by 2 is a constant. We have the right hand side e power 2x, e power ax, replace d by a. So 1 by a value is 2, 2 squared minus 4 e power 2x minus 1 by 2. What is happening? 2 square will become 4, 4 minus 4 will become 0. I said put a cross, do not consider it. That is the meaning. Multiply by x here. Differentiate the denominator with respect to d. So d square 2d. Then this is there as it is. E power 2x e power minus 1 by 2. Now find out, replace d by 2, x by 2 into 2 e power 2x e power minus 1 by 2. So what is my total answer? X e power 2x e power minus 1 by 4. Sorry, if 2 2s are 4, 2, 8, totally multiplied. 2 2s are 4 into 2. This is particular integral 1. Same way, particular integral 2, 1 by d square minus 4 e power this factor minus 2x e power 1 by 2. Replace it 1 by 2 square or minus 2 square, sorry, minus 2 square, because a value is minus 1. Again what you have observed, it is 0, minus 2 whole square, 4 minus 4, so leave it. Again multiply the numerator by x, differentiate the denominator with respect to d, so 2d e power minus 2x e by 2. Now replace it x by 2 into minus 2 e power minus 2x e power 1 by 2. So totally the answer minus x e power minus 2x e divided by 8. Here plus, there minus. This is a critical case where the denominator becomes 0. Again I am telling, you multiply by x, differentiate the denominator with respect to d. Now one more is there, we have to find the particular integral 3. You see that I have converted it into in terms of exponential, therefore 1 by d squared minus 4 e power x log 3. Same way a value is here log 3 e power ax, a value is log 3. So it will become e power x log 3 divided by log 3 whole square minus 4. I would like to advise, don't find the values of all these log 3 and all those things, you write as it is, because this is base e. If you get confused with base 10, answer will become wrong, not required, only this much is sufficient. Same way here this answer is sufficient. So what is the total solution of the given differential equation? It is complementary function plus particular integral 1, 2 and 3. Therefore the solution is y is CF plus PI1 PI2 plus PI3, that is C1 e power 2x, C2 e power minus 2x, then x e power 2x e power minus 1 by 8 minus x e power minus 2x e by 8 plus, you can write e power x log 3 also or 3 power x, not a problem, by log 3 whole square minus 4. This is my complete solution of the given differential equation. In the textbooks what happens, in some textbooks these two combined together they have written it as sine hyperbolic, which all those things are not essential. If you do it particular integrals and write the solutions, it is sufficient. So this is one indirect form where you will get cos hyperbolic. Now let us see a problem for sine hyperbolic. What is the only change? E power ax plus e power minus ax by 2 for cosine, e power ax minus e power ax by 2 for sine hyperbolic. So let me take the next question. Y double dash plus y dash plus y is equal to sine hyperbolic 3x, again 5 power x. What is the first step? What is my standard form? D square plus d plus 1 into y. Here sine e power 3x minus e power minus 3x by 2, again plus e power log 5 power x, which we have done in the previous question. So, if I simplify d square plus d plus 1 into y is equal to e power 3x by 2 minus e power minus 3x by 2 plus e power x log 5. What is the next step? Auxiliary equation is m squared plus m plus 1 is 0. What are the roots? M is equal to 1 by 2 minus plus or minus I root 3 by 2. By any ways you can find, in all my classes I am keep on telling this, whether you want to factorize it, you want to use calculators, whatever may be the method, we want only the roots. Then what is the complementary function? E power minus 1 by 2x c1 cos root 3 by 2x plus c2 sin root 3 by 2x. This is the complementary function. As we have done in the previous problem, find pi1 for this, pi2 and pi3. So, pi1 1 by d square plus d plus 1 e power 3x by 2. This is equal to, instead of d, 3, 1 by 3 square plus 3 plus 1 e power 3x by 2. Simplify 9, 10, 13, 13 into 2, 26. So, e power 3x by 26. Here not known denominator never becomes 0, directly replacing it. What is pi2? 1 by d square plus d plus 1. Be careful. You take the negative symbol also here only. Usually we advise, because when we write the solution, it is our customary CF plus pi1 plus pi2, you may forget that minus symbol. So, if you take here itself the negative symbol, you get pi properly. So, 1 by minus 3 whole square plus minus 3 plus 1 minus e power minus 3x by 2. So, 9, 10 minus 3. 10 minus 3, 7, 7 2s are 14. So, minus 3x by 14 is my second particular integral. What about the third one? Already we have seen, same way, 1 by d square plus d plus 1 pi3, 1 by d square plus d plus 1 e power x log 5. As I already told, no need of any simplifications, simply substitute instead of d log 5 and leave it, log 5 whole square, log 5 plus 1. Then what is the solution? The solution is y is equal to CF plus pi1 plus pi2 plus pi3, that is y is equal to e power minus 1 by 2x c1 cos root 3 by 2x plus c2 sin root 3 by 2x plus e power 3x by 26. Here you see that minus is taken care. So, minus 3x by 14. Finally, e power x log 5 divided by log 5 whole square plus log 5 plus 1. This is the complete solution of your particular differential equation. So, this is how we should do the problem. These two are indirect forms, sine hyperbolic and cos hyperbolic. One more critical form is denominator becoming 0. This is called type 1 of differential equations. Now, let us move on to type 2 differential equations. Already we have discussed, I have shown you the slide with all the 5 types. So, type 2 equation will consist of sine or cosine function, sine bx plus c or cos bx plus c. B and c are constants. Sometimes the c may not be there also, only sine 3x, cos 3x, sine 4x, cos 4x, like that they may give. What is the condition? Very important, be careful, because usually we should see the students make mistakes in this. Be careful. See what you should do, you should replace d square by minus b square for sine bx plus c or cos bx plus c. Okay. This is not minus b whole square. Minus b whole square means I might have written b square only, which is not correct. It is minus b square. And very important, no substitution for d. No substitution for d. In type 1 we said replace wherever d is there as a, but here you should be very careful. I can use d squared as minus b square, but for d there is no substitution. That is what we have given. Type 2, okay, if RHS of differential equation is sine bx plus c or cos bx plus c, then to find pi, replace d squared by minus b square. Very important, no substitution for d. Only d square should be replaced by minus b squared. There should not be any substitution for d. Remaining process is same. You have to find the complementary function. Solution you have to write CF plus pi. Only finding the particular integral is different idea. Let us go for a problem now. You may ask what happens if we get d in the problem. We see there, we will multiply and divide by the conjugate and we make it perfect. So, y double dash minus 4y dash plus 3y is equal to cos 2x. This is the question I am taking. Y double dash minus 4y dash plus 3y is equal to cos 2x. What is the first idea? Don't forget, we have to follow the procedure. 4d plus 3 into y cos 2x. Auxiliary equation. These all are standard notation, standard form. Auxiliary equation. M squared minus 4m plus 3 equal to 0. What about the roots? By now if you have calculated, you can write 1 or 3 different roots. So, what is my CF? C1 e power x plus C2 e power 3x. This is my CF. Now, most important part, the particular integral. See carefully, particular integral 1 by d squared minus 4d plus 3 cos 2x. As I said, now only b value is available, cos bx plus c, only b value is available, which is 2. C value is 0, no problem. C is not necessary also. For us only b value is important. What we said, d square should be replaced by minus b square. B value is 2, so minus 2 square. See this, minus 4d, no substitution for d. I am keeping it as it is. D as it is, constant as it is, only in place of d square we have written minus 2 square. Simplify this, 1 divided by, this is minus 4 plus 3. So, you will get minus 1, minus 1, minus 4 plus 3. If you want, you can take this minus outside, minus 1 by 4d plus 1 cos 2x. We can write the conjugate, whatever the way we want we can write. See, 4d plus 1, I will multiply numerator and denominator by 4d minus 1. You want to write 1 minus 4d, that is also allowed, no problem. Anywhere one sign should be changed, which is called conjugate. So, what I am doing? Keep the minus as it is, 4d minus 1 in the numerator, denominator already 4d plus 1 is there, I am multiplying by 4d minus 1 only. So, the equation is satisfied, multiply same value in the numerator and denominator, 4d plus 1, 4d minus 1, 4d minus 1. What is the advantage? Denominator is looking like a plus b into a minus b. So, a square minus b square, 16d squared minus 1 squared, a plus b into a minus b, a squared minus b squared. So, a plus b into a minus b. So, a squared 4d squared, 16d squared 1. Now, we do it again the process. 4. What is meant by d? Already we told, it is d by dx. So, differentiation of cos 2x, 4d of cos 2x, differentiation of cos 2x, which is minus 2 sin 2x minus cos 2x divided by 16, again d squared is there, minus 2 squared minus 1 squared. See the process again, 4d into cos 2x. So, 4 as it is, differentiation of cos 2x minus 2 sin 2x minus 1 into cos 2x. Again in the denominator I have d squared. So, for d squared I can replace minus b squared I have written. So, what is my total answer? Minus 8 sin 2x minus cos 2x divided by, here you will get minus 65, this minus is getting cancelled, plus 65. Am I right? 16 into 4, 64, 1, 65. I will get minus 65, this minus is cancelling with this, therefore plus 65 numerator as it is. Therefore, finally, the solution is y is equal to Cf plus Pi. Write all the values, C1 e power x, C2 e power 3x plus minus 8 sin 2x minus cos 2x divided by 65. This is the solution. So, replace d squared by minus b squared, there is no substitution for d. What happens if I get d in the denominator? I can multiply divide by its conjugate, so that in the denominator once again the d can be changed or multiplied as d squared. Then you can use once again d squared as. So, one example for cosine function we have seen. Let us take one more example for sine function. Procedure is same, no doubt. Replace d squared by minus b squared, that is a procedure we apply. Y double dash plus 4y dash plus 4y is equal to sin 3x. You can see whenever I take a problem, all the conditions we are taking. First I took unequal intervals, sorry, roots. Here you will get equal roots. 3 process for to find the complementary function. So all the 3 keep on repeating in all the cases. Now standard form is d square 4d plus 4 into y, it is sin 3x. What is your auxiliary equation? M square plus 4m plus 4 equal to 0. Find the roots, minus 2 comma minus 2. Again and again I am repeating, when you use calculator, be careful, you will get only one root, x equal to, other you have to assume it, equal roots. What is your CF? C1 plus C2x into e power minus 2x. Now particular integral 1 by d square plus 4d plus 4 sin 3x. Replace d squared by minus b squared. So 1 by minus 3 square plus 4d plus 4 sin 3x minus 9 plus 4. So it will become minus 5. So 1 by 4d minus 5. This is 9, minus 9 plus 4. Multiply and divide by its conjugate again. 4d plus 5 by 4d minus 5 into 4d plus 5. Multiply and divide by its conjugate, already it is there, sin 3x. Now 4d plus 5, denominator 16d square minus 25, 5 square, 25 sin 3x. Now 4 into d of sin 3x, that means differentiation of sin 3x, which is 3 cos 3x plus 5 sin 3x divided by 16, again apply the procedure, minus 3 square minus 25, again minus 3 square 9, okay, multiply everything, you will get I think minus 169. So 12 cos 3x plus 5 sin 3x divided by minus 169, 16 into 9, then 25 added with the negative symbol, correct. Now what is the solution? Everywhere total problem should be completed, that means with the solution CF plus PI, y is equal to C1 plus C2x e power minus 2x plus 12 cos 3x 5 sin 3x divided by minus 169, that is the solution. Same way one more problem is given, y double dash plus 2y dash plus 2y is equal to sin x. You can try the third problem, solution is also given, it will give you complex roots minus 1 plus r minus I, then for sin x you can find the solution. Third problem you can work as a assignment. Now there is a common procedure to find the solution of second type, that is whether it is a sin bx plus c or cos px plus c. You may ask, as in type 1, is there any indirect questions? Is there any critical questions? In type 1 what we said, critical, if the denominator becomes 0 it is called critical problems. Indirect, sin hyperbolic and cos hyperbolic, those two are indirect questions. Yes, in type 2 also we have indirect questions and critical questions. What are the critical questions? Let me give you two examples. As same way the denominator will become 0, which is called critical problems of type 2 as in the type 1. In type 1 also we said the same thing. If the denominator becomes 0, it is critical. Same way this one. See this question, y double dash plus 9y is equal to cos 3x. Standard form, d square plus 9 into y cos 3x. Auxiliary equation is m squared plus 9 is equal to 0. M squared is equal to minus 9. M is equal to plus or minus 3i. Usually we write 0 plus or minus 3i because m1 plus or minus im2. Now what is my CF? E power 0x c1 cos 3x plus c2 sin 3x. This is my complementary function. Go for the particular integral, 1 by d square plus 9 cos 3x. See this, what we said, replace d squared by minus b squared. So it is becoming 0 denominator, d squared by minus b squared. So minus 9 plus 9. Same way, don't consider it. Multiply by x in the numerator, differentiate the denominator, 2d cos 3x. See, there are two ways to answer this. Whichever is easier for you, you can choose it. Be careful, there are two ways to find the solution afterwards. What we can do, multiply by d in the numerator and one d in the denominator. Please note that this x by 2 is separated over the job. So that means I can write x by 2, numerator is d, denominator is d square cos 3x. There are two ways to find it. X by 2, what I have done, multiply by d in the numerator, d in the denominator. So it will become d by d square cos 3x. Now x by 2, differentiation of cos 3x minus 3 sin 3x by minus 3 square, d squared by minus b squared again. Differentiation of cos, don't include this into the differentiation. If I multiply by x, that is denominator becoming 0, then the job is over. So x by 2 separated, multiply by d in the numerator and denominator, differentiation of cos 3x, d square. Now simplify this, it will become 3x sin 3x divided by 9 2s are 18. In other words, x sin 3x by 6. X sin 3x by 6. Sir, this many number of steps we have to do? No problem. What is the other method? X by 2, but you should remember, we are applying the inverse differential operator method. We are applying inverse differential operator method, I said. So 1 by d, we said d by dx, differential operator, 1 by d, it will become an integral operator. So 1 by d, integral of cos 3x dx. D is differentiation, 1 by d is integration, that is all. So this is equal to x by 2, what is the integration of cos sin 3x by 3. So I will get x sin 3x by 6. You can see by any method the answer is same, no change in the solution. It has some steps? No. See, why we do this, or multiplying by d, dividing by d, the factor already we know that. That is why this method. Since 1 by d is there, I can use integration also. Therefore, what is my complete solution? The solution is y is equal to Cf plus Pi. That means C1 cos 3x plus C2 sine 3x plus x sine 3x by 6. Okay, here e power 0 is 1, that is why only that much. You may ask, sir, whether it can be possible for sine also. Yes. One more problem I will show you, y double dash plus 16y is equal to sine 4x. We take that. All procedures you have to write the standard form, auxiliary equation, correct. So, standard form is d square plus 16 into y sine 4x, auxiliary equation m square plus 16 is 0, m squared is minus 16, m plus or minus 4i as previous problem. I should write 0 plus or minus 4i. What is my CF? E power 0x c1 cos 4x plus c2 sin 4x. Particular integral 1 by d square plus 16 sin 4x. Replace it 1 by minus 4 square plus 16. Again I can see minus 4 square minus 16 plus 16, leave it. Multiply the numerator by x, differentiate the denominator, sin 4x. I am using the easiest part only, x by 2. 1 by d means it is integration. Be careful that x will not come into the integration part, only sin 4x. What is the integration of sin 4x? Minus cos 4x by 4. So, minus x cos 4x by 8. Therefore, the solution is y is equal to CF plus PI. So, y is equal to C1 cos 4x plus C2 sin 4x minus x cos 4x by 8. So, this is how you, if the denominator becomes 0, how we can work. This is the type 2 method of problems. What are some more ideas? See here, I have done first question cos 2x, second question sin 3x, you have to work this sin x. In sin x, what is the value of b? B is 1. So, replace d squared by minus 1 squared. So, you will get complex roots, that is why in the solution you can say c of part e power minus x c, and this is going to be your solution, sin x plus 2 cos x by 5. This is a problem for first idea, basic idea of type 2. Now, we have done these two questions, cos 3x and sin 4x, the denominator becomes 0. Same way you can work these two questions, y double dash 49y cos 7x, you will get plus or minus 7i. So, c1 cos 7x, c2 sin 7x, then x sin 7x by 14. Here you can see if you replace d squared by minus 7 squared, 0, multiply by x, divide by 2d. So, 1 by d is integration. So, integral cos 7x, you will get this solution. Same way for sin x, one problem. So, this you have to work. These are called indirect problems of type 2. First direct, cos is given directly, sorry, this is critical, denominator becoming 0, it is critical problems of type 2. What are all indirect problems? All the results what I am showing you now, the trigonometric relations, already in lower classes you have learnt it. We want 8 trigonometrical ratios or relations. One 4 with the powers and 4 is called transformation results. That is 2 with square, 2 with cube. See the first one, you can recollect the ideas in the lower classes, you already know this. Cos square a, it is 1 plus cos 2a by 2. Then sin squared a, it is 1 minus cos 2a by 2. We do not have formula for cos cube, that is why both the steps are written here. We do not have formula for cos cube, we have formula for only cos 3a. What is my cos 3a? 4 cos cube a minus 3 cos a. From this I can find out what is my cos cube. This 3 cos a goes to the left hand side. So cos 3a plus 3 cos a divide by this 4. So 3 by 4 cos a, this one. Then 1 by 4 cos 3a. Same way the fourth ratio or relation sin 3a. 3 sin a minus 4 sin cube a. From this find out the sin cube. 4 sin cube to the left, 3 sin a minus sin 3a, then divide by 4. 3 by sin a minus 1 by 4 sin 3a. These 4 results for power we say, square and cube. 4 results we should remember. What are the other 4? Other 4 are called transformation results. Sin a cos b, it is sin a plus b plus sin a minus b by 2. Cos a sin b, sin a plus b minus sin a minus b by 2. You may ask, sir, what is the difference between these two? Please note that when I use this 4 transformation results, a value should be more than b, a greater than b in the 2 trigonometric ratios whatever they have given, sin a cos b. Okay, you see that you convert the problem in such a way that a should be greater than b. That is why 2 results, sin a cos b, then cos a sin b. Then cos a cos b, cos a cos b is cos a plus b minus cos a minus b by 2. Cos a cos b, cos a plus b minus cos a minus b by 2. Finally, sin a sin b. See, people are remembering this formula in 2 ways, whatever it may be your method. People write actually minus of cos a plus b minus cos a minus b, which is nothing but if I multiply the minus inside, this is the other form, cos of a minus b minus cos a plus b by 2. What we are observing, why we need this trigonometric relations or the formulas? We have type 2, either it should be a sin bx plus c or cos bx plus c. We do not have the method to do whether it is a square, cube, multiplied, 2 relations are multiplied. For those things I cannot find the solution using my type 2 method. They say replace d squared by minus b squared. So I should convert my right hand side to the known form in these things. How you can see once again, cos square, cos cube, sin cube. What happens on the right hand side? You will get a plus symbol or minus symbol. The terms are separated. So I can find pi1, pi2, pi3 like that, then I can add my solution. Here also same thing, another 4 results. Transformation, product is there, sin a cos b, cos a sin b, cos a cos b, sin a sin b. For that also I should separate the trigonometric relations so that I can find pi1 and pi2. These all are called indirect forms as we said in the type 1. Sin h, cos h are the indirect forms in type 1. Same way these all are called indirect forms of type 2. Now let us take a question. D square minus d plus 1 into y is equal to cos square 5x. I have taken square form here. What is the formula I have shown you? Cos square A. Cos square A is 1 plus cos 2A by 2. 1 plus cos 2A by 2. Correct? So, same way 1 plus cos 2A formula you can use. You can use. So, 1 for cos square, then one more problem for cos product. Okay. So, these indirect forms let us see in the next class. We have seen direct forms, these two indirect forms we see in the next class. Thank you.